Okay, I got two more problems I'm going to go through with you guys. Number 17 right here is one of those. All right, a rectangle has a perimeter of 32 inches. The width is 6 inches and the length is the square root of x plus 5. Solve for x. What is the length of the rectangle? So now notice here, it initially tells me to solve for x. And so it's telling me right now that that's what it's wanting me to find. So first thing that I'm going to do is I'm going to go, okay, so I got 32 is equal to, because that's my perimeter. Actually, hold on. Let's think about this really quick in terms of an equation. Perimeter and length and width. So what is the perimeter of a rectangle? Well, the perimeter of any shape is all sides added together. So if I have a rectangle, I have this little rectangle here. So let's say this would be width, this would be length, this would be width, and this would be length. So I have W plus W, or rather 2W, and I have length plus length, or 2 length. So my perimeter is twice the width plus twice the length. So I have to make sure that I take into account that it is 2 times both of those sides. It's not just 1 times 1. If I did multiplication of length times width, that's my area. That is not perimeter. So perimeter would be 32 is equal to, the width is 6 inches. So I have 2 times 6, because there's my W. And the length is square root of x plus 5. So plus 2 times the square root of x plus 5. So again, I'm going to be solving for this x right here. So I've got to get everything away from it. I can go ahead and multiply this 2 and 6 together. So that's going to get me 32 is equal to 12 plus 2 square root of x plus 5. Okay, next step would be to go ahead and subtract this 12. Don't fall for the trap that so many people do. I cannot combine these two. This is 12 plus 2 times the square root. I cannot combine those. If I gave you 12 plus 2x, you would not say that that is 14x now, would you? So do not try and do that here. Do not fall for that trap. Instead, I'm going to subtract 12 from both sides, and that'll get me 32 minus 12 is going to get me 20 is equal to 2 square root of x plus 5. Okay, sorry, I ran out of room, so I decided to move it off to the side. So over here, now, again, I can divide both sides by 2. I do not want to square yet because this square root is not by itself. So then I get 10 is equal to the square root of x plus 5. Now the radical is by itself. So since that is by itself, now I can go ahead and square both sides. Not before it's by itself. I cannot do that. So now that gets me 100 is equal to x plus 5. And then I could go ahead and get x by itself by subtracting 5 from both sides. And so that gets me x is equal to 95. Now note, that's exactly what they asked me to do here, solve for x. Now that's part of it though, because the next part is what is the length of the rectangle. So if I solve for x here, that is not the length of the rectangle, because remember that the length of the rectangle is the square root of x plus 5. So my length is actually going to be the square root of 95 plus 5. Well, 95 plus 5 is 100, so that just gets me the square root of 100, which tells me the length is 10. And it tells me inches right here, so it'll be 10 inches. Okay, so that's how I would do a problem like that. All right, now the last problem I want to introduce you to is this problem right here. First, I did not make this problem up. The county did. Don't judge me. It's a little crazy. All right. Antelopes are native to Africa and Asia. They range in size from 12 inches at the shoulder, pygmy antelopes to giant elands, which are over 6 feet tall at the shoulder. Most antelopes are between 3 and 4 feet tall at the shoulder. The horns of antelopes, unlike antlers of deer, are unbranched, are made of shell with a bony core, and are not shed. The below data represents the length and mid-shaft diameter of humerus bones of African antelopes. Okay then. So in order to do this problem, you're given a whole bunch of data. Note that it says right here, x equals diameter, y equals length, and I'm given all of these values. Truly, the only way to do this is to make what is called a regression equation. And so we're going to do what is called a power regression. So what you're going to do is you're going to go into your calculator and you're going to input all of this information into the table. So right here, if I go ahead, pull up my calculator, what I would do is I'd go right here to stat, which is right next to where you have your alpha button, the variable button, and stat. So I'm going to go into stat and I'll hit edit right here. And then so now you have these list values. In L1, you're going to go down the column, entering all of the values that you were given on the table for your X values. So 17.6, 26, 31.9, 38.9, 45.8, 51.2, so on and so forth. So I'm going to go ahead and enter all of these values in really quick. Now, I've gone ahead, gotten all of those numbers entered in. Whenever you do, I encourage you to definitely go back through and double check and make sure that they're all entered correctly. Now that they've been confirmed to all be in here correctly, what you would do from here is you would hit the stat button right here. Now, instead of hitting edit like we did to enter all of those into the table, we're going to scroll to the right to calc, and then we're going to scroll up to power regression. So you see right here, that's the letter A, PWR-REG. That's the thing that we're going to want to have. All right, and so within this power regression screen that you're going to be on now that you clicked on power regression, notice right here it says X list L1, Y list L2. Well, that's exactly what you did, was you entered all of your X variables into L1 and you entered all of your Y variables into L2. Now we're going to use that information to go ahead and go on to the next parts here. And so we would go ahead and go down here to calculate. When you go to calculate right here, once you hit enter again, it's going to create the equation for you. Now, notice right here at the top of the screen, it says y equals a times x to the exponent of b. So let's come back here into what we've got here on our screen. So it's y equals a times x to the power of b. It doesn't quite look like these problems. These are square root problems. Or even cube root problems. Well, let's see what we can figure out. And if I come back over here into this, I'm just going to go ahead and rewrite the information down on my screen. So I've got 24.132. And if I come back over here, 24.1. Oh, okay, so at least that matches. So I got y equals 24.1. That matches that a value. And then I have x to the exponent of b. And over here, b is 0.659. Okay, so we'll do 0.659 as my exponent. Now, let's think. Is there another way that I can write this radical that I have right here without having a radical? I could write it with a fractional exponent, right? Well, how would I do that? That would be 24.1 times x to the power of 3 halves. Remember, my index here is 2, and so that becomes the denominator of my exponent. So it's divided by 3 halves. Well, that's a decimal, isn't it? 3 halves is a decimal. It's equal to 1.5, isn't it? Okay, maybe we're onto something here. Well, 1.5 is not 0.659, so it's not going to be that one. So let's try some other ones and see what we get here. Okay, so if I do B. So again, that's going to get me 24.1 times x to the 5. And again, my index here is 2, so this is going to be 5 halves. Okay, well, 5 halves, what is that as a decimal? That's 2.5. Okay, definitely not going in the right direction. That's not the one I need. All right, let's try this next one. 24.1, and this written as a fraction would be 4 thirds. Okay, 4 thirds as a fraction is 1.3 repeating. Okay, we're getting close-ish. We got, closer than 1.5. All right, let's try this last one. This has got to be it, right? 24.1 times x to the power of 2 over 3. Ooh, what is 2/3 as a fraction? Why? Let's look at that. And so we can kind of see and confirm 2/3 is 0.6 repeating. And when I come over here, this is 0.659. That is pretty darn close. And it asks me to find the function that best models. So that would be this one. And to be completely honest, if I went ahead and I used that as my equation, what I could do right here, I'll show you on the calculator just so you can kind of see. Let's put this in. If I put in here 24.1 times the cube root, come on. I'm not trying to do, that's what's, here we go. Maybe. There it goes. Cube root, come down here, cube root of x to the power of 2, so x squared. Oh, it didn't do x. I didn't do x. Man, things going bananas on me over here. Okay, so now we got that. Go ahead and I can put that in, and I'm going to turn on my stat plot so that I can see all those things that I graphed. I'm going to hit zoom and I'm going to go ahead and hit stat so that I can see all the things I plotted. And those are all of the plots that we created in our L1, L2. And that equation right there that I just put in is the one that we put on there. And you can see it actually does resemble it pretty closely. It goes through a lot of the points and it's quite close to each one of them. And so that's why that is going to be the equation that we're going to use. So again, this is how you would find something with a regression equation, and you would have to do this anytime you're given a table with a bunch of data points. Hopefully that helps you out through all of these problems and gets you through anything that you have questions on.